Welcome to Brain Vision.
We have an observed wavelength of lambda equal to 94.96 nanometers, which I convert to meters, when an atom transitions from some higher orbital down to the first ground state. So n final is equal to 1. So what we want to do here is use the equation for wavelength relative to these orbital transitions to find n sub I, which is some integer value for the initial. So what we can do is we can start to rearrange the equation to solve for this. So we have 1 over n sub I squared is equal to the first. We can divide both sides by r sub h, and then we can then add or subtract 1 over n sub f squared over to the other side of the equation and deal with that negative sign. So this is a negative sign. So we have 1 over lambda r sub h, where r sub h is the Rydberg constant, minus 1 over n sub f squared. Then we can multiply through by -1 to get rid of that negative sign. So that becomes a negative, and that becomes a positive. And then to get the value out of the numerator, we raise both sides to the -1, and then we need to take the square root to get rid of the squared value. So we have n sub I is equal to 1 over n sub f squared minus 1 over lambda r sub h squared, where the Rydberg constant is 1.097 times 10 to the 7 inverse meters. And this is all raised to the -1/2 because we raised it to the -1 to get it out of the numerator and into the denominator. And then we took the square root, which is the same as raising it to 1/2. So carrying out this operation, we find that n sub I is equal to approximately 5. Part B wants to know if this could be a part of the Paschen series. But the answer here is no. And that's because if you look it up, the Paschen series is the infrared, and this is in the ultraviolet. So we can say no, because the Paschen series is in the infrared. Then part C says, what about the Lyman series? Could this be a part of the Lyman series? Well, if you look up the Lyman series, there is a wavelength equal to 95 nanometers. And our 94.96 is approximately 95. So we could say lambda, which is equal to 94.96 nanometers. This is approximately equal to 95 nanometers, and a value of 95 nanometers is in the Lyman series. Oh, sorry, but it asked for the Balmer series, not the Lyman series. So if you check the Balmer series, I was looking at the wrong series. I apologize about that. Part C wants to know if it's part of the Balmer series. So looking that up, we see that the Balmer series is all in the visible wavelength, and our value is not in the visible wavelength. It's in the ultraviolet wavelength. So we say no, because the Balmer series is in the visible wavelength. So if it would have been the Lyman series, then the answer would have been yes. Sorry, I was looking at the wrong series there. So we can box that in as our solution for part C.